Hi guys, welcome to my new video on microservice cloud config server. So in the microservice world, cloud config server is an important part. So we'll talk about that. I'll give you some examples how exactly you can configure cloud config server. So let's start. So the agenda will be first, I'll explain about what exactly Cloud Config Server is. What is the importance of a Cloud Config Server? Why do we need it? What are the other available tools for managing this configuration? And then we'll go with some example. What is the load strategy of a client application and how the refresh mechanism works in a client application? So these things I'll cover as part of this video. And for more videos on microservices and other features of a Java application, you can subscribe to my channel. So next thing, very important thing, first we should understand about what exactly application configuration is. So application configuration, if you talk about a Java application or any distributed application mostly, then application configuration is kind of separating out your constants. So in the application you will have constant like your database properties, your log label, your application name. These things we separate it out so that we can change it frequently, like from one environment to another environment. We can change it very easily just by referring to the properties file instead of changing it at the code level. So this is application configuration. Mostly in a Spring Boot application, this is stored either in application.property, which is a kind of property file, and other alternative is YML also is there where we can store it, application.yml. So after that, next thing is, why do we need tools to manage this configuration? We have this property files. Now we can store all the properties inside property file, but why do we need some other tool to manage it? When we go from one application or application where we have a less number of services, like one service, two service, then it is fine, we can manage with the help of property file. But we if we move from a single small scale application to large distributed application, then for sure we need configuration management tools which can manage the complete environment. Like a distributed application which consists of more than 5 application or more than 10 application requires these kind of configuration management tool. Then only you can have the management. Even if for each environment, like consider your application is there in your dev box, dev machine, you have applications. For that you will need a separate properties. Then you move your code from dev to stage or QA, then there you will need some separate set of property. Again, for production you need separate set of property. For managing these many different set of properties and the complete infrastructure of properties, you need tools like this. Also, it is very easy to separate it out, and after separation easy to maintain also. When the code is totally separated from the properties, you don't have to redeploy your application, you don't have to restart every time your application for just changing the property files. So this is the benefit of using a configuration management tool. So we'll see what are the different types of configuration management tool we have. So some of them are like Chef we have, Puppet we have, Ansible we have. So these are like very popular tools for configuration management, but they have some drawbacks right now. They have drawbacks like deployment oriented. It is basically deployment oriented means when you want to make any changes to your application or to your property file, you have to redeploy your application, and that is a big burden for application deployment. Uh, Consider you want to just change the logging label from logging label debug to warning, then you have to restart all of the application which are running so that it will take your new changes. So this is a problem in terms of deployment. So every time you have to restart it. We have some more problem, it is not even dynamic. So this Chef, Puppet, and Sybil, there should be a server which should be aware of what are the IP address of all the applications so that it can push all changes to this IP address. By using that only, it can deploy your changes. So that is also kind of the Chef or any configuration management tool has to keep track of all the services, then only it can do the deployment. So this is also one of the challenge with the configuration management tool which we have like Chef, Puppet, and Ansible. So for that purpose, we have another set of tool which is kind of config server or cloud config server, which can manage your configuration, which can hold off your configuration throughout the application. And for the purpose of managing it, it is very easy through config management. So how the architecture will be for a config management tool, we'll see in our upcoming slide. First, what are the benefit cloud config server provides? So it is implemented over the model. Pull strategy, what it does it, so when you apply any changes to your configuration file, so it will be pulled by the application. So whatever the application which requires those property will pull it instead of pushing it from Chef or Ansible. They will do a pull model where they will deploy into the application. Here, application itself will pull all those changes. Also, the this config server provides with HTTP based API so that you can expose your services through HTTP and you don't have to redo a new kind of protocol implementation in your application to get all these property. It also provides encryption decryption of property. You can do encryption decryption on the fly of your cloud config server can support it. And this also does not require a complete redeployment, so the application does not needs to be redeployed for accepting all those changes. So these are some of the benefit this guy provides. So what are the key components of a cloud config server are, like it provides configuration repository. So we'll see about what are the different type of repositories we have. The second component is configuration server, where the server will be which will manage your application, manage your all the repository or all the application properties. So server will manage those. Then we have client, so the application client which will require all these property, those are called as application client. So this is the actual architecture it will follow. Like you have some property, as I told that Spring Boot application uses some property files, or Java application uses some property file where it store all the configuration for a set of environment or for a particular application. So for that purpose, we can create a separate repository. Repository means by either a Git repository or a SVN kind of repository, or even we can go with Vault kind of system also, where we can store all this property. So in the property file, we'll make all the changes and we'll push it into the repository. Like Git, what we can do is we can just create a property file, like for this application delivery service. If you want some property to be managed, we can store the delivery service dot property file in the configuration server or configuration repository. So then the configuration server can pull it and deploy it into all this application, or this application can pull it also and use those property file. So here in the configuration repository, what we'll do is we will maintain all this property file needed for application delivery service or user service. For each application, this property will be maintained here in the configuration repository. Get SVN Vault, either of them you can use for. Then configuration server is the second component. Configuration server will do a pull to your repository every time. Whenever changes happens to your repository, configuration server will pull those changes, and then those changes will be available through the REST service at the configuration server side, and the config client can pull those. So this will be the architecture. Also, the config client application has to have some logic of pulling this property file from config server. That has to be there. So this everything is already provided by cloud config server or Spring Cloud config server. We have already a pre-built configuration server. We have to use the annotation and it will give you a ready-made configuration server. And we have client implementation also. Spring Cloud provides the client implementation. You just have to have the dependency and some of the property file changes, then it will become a client application which will be capable of pulling all those changes from configuration server. So this architecture is already present in Spring Cloud the repository, you can just clone those repository or in your pom.xml and start using it. So let's go to the next thing. So as I told, the what are the key components of a configuration server. So first one, as I told, configuration repository is there, like the file system, Git, Vault, encryption, decryption. These are kind of some of the example of repository. You can use a normal file system for maintaining all the properties, or you can use a Git. Vault is also one way of secured way of storing your property for application. So either of the way we can use the repositories. So next component is like configuration server. For creating a configuration server, as I told, Spring has already provided this implementation. You just have to have this dependency in your application, and based on that, you will get this annotation in your application. So in the Spring Boot application, you have to add this annotation in the main class, enable config server, and this will enable a server which will be capable of holding all those repositories, pulling all those repositories. Then we have to configure that repository by using some configuration in the application.property. Like just we are changing that server dot port here, just for the purpose of simplicity. It is not required to change the server dot out for all the scenarios. This is the compulsory. Second configuration is necessary for any configuration server, so that you can provide the path of what exactly the path of your property files repository. So here, if you want to go with the file system to maintain all the property file, you can go with file system by using the file protocol, and then you can define the path. So this way it will start pulling this all the property from this repository. Or if you have a Git repository, you can use it like this HTTP based Git repository. By this, you will have a ready-made cloud config server where you can have uh, a repository where it will start pulling whenever you make any changes from into the repository. This application will have your latest configuration properties file. Next thing is, like as I told, this works with the HTTP model. So Cloud Config provide already inbuilt HTTP supports also. So for that purpose, we have a naming convention. API resources are named like this so that you can access the your property files over the HTTP protocol. So REST service is provided. If you see that, the first component is application. This is the name of the application. The second component is profile. This is for the active profile. Like in Spring, we can manage multiple profile like dev profile, or a set of property which is required for dev, a set of property which is required for stage, QA, production. So you can choose between which property profile you want. Based on the active profile, automatically the client application will try to pull this kind of properties. And label is also one of the optional field. It is not compulsory. Like if you want to switch between a branch, say that you have a set of configuration in one branch and another branch is little bit different. So you can switch between those branch of Git so that you can choose the set of property, previous property or the latest property. In between you can have a switch between. And the second API is a very simple API. It says that application name and hyphen profile, and YML is type of property. It will give you an input output of type a YML formatted your properties. You can see all the properties here. And also you can choose for a dot properties. If you change the extension to, then you will get in the property file format. We have these many different types of API already provided. So for that example is like, if you want the application client application name is config client app. So this is the name which is defined inside the client application, and the client application need a dev profile. The active profile is a dev profile. Then you can request for this in your HTTP request, and this will give you the property required for this dev profile and the application with this one. So next thing is cloud config. So how does it load all this configuration, and how does it in the Spring world, how it manages all. So we'll see the example first, and then we'll go into this details. So let's go to the example I have prepared here. So for configuration server, how to create a configuration server, this is the one configuration server application I have created. Let's try to see what are the details is required here. The very first thing is needed is a repository. Before starting the application, I have created one Git repository. So this is the Git repository. You can see that .git folder is initialized. So this is just a plain Git repository with these files. So as I told, we will maintain all the property files for the client application. So my one of the client application is config client app. So this will be my client application name. So based on this name, I can choose either the default property, which is a config client app, or I can choose a profile based property also, config client app hyphen dev dot property, so that it will load the dev profile activated properties for the application. So this is the naming convention. The first set of name is divided into two part. First is the name of the client application. Second is the active profile. Based on that, I have defined some basic properties inside it, like property one, very basic example I'm providing, property one from default. So this is the default property. I have given the property value. And another is client config app hyphen dev is another property file, which is for the dev active profile as dev. So in this is the property I have provided. Again, the property one, and the value is from dev hyphen updated. So based on this, if the client application have the active profile as dev, will get the property one value as this one. And if it is the client application does not have any active profile, then it will load this property file. So we'll go to the second thing. So this is the repository we have created. If you see, this is a very basic repository where you have these files. So next thing is cloud config server. How do we have configured the cloud config server? So let's go to the code. So this application I have created with the dependency. As I told that we will need a Spring dependency. So what are the dependency we need? So cloud config server dependency we need, and actuator also have kept it for the purpose of enabling refresh and other strategies here. So the most important thing dependency we need here is Spring cloud config server. This is the dependency we need. So after this, we can enable the cloud config server. Even if you want to create a example server for yourself or for your company, then you can go to start.spring.io directly, and here you can create an application. Here you can choose for the dependency, and this will provide you a ready-made application with all the dependency configured. Like if you want cloud config, so you can choose the cloud config server dependency, and you can give your artifact name, group name, and you can just download the application. So this way you can download an application of a Spring Boot type, which will have basic dependency already configured. After that, what you have to do is you have to configure some of the properties. Like I have configured, as I told that I'm changing the server dot port property here. So this is not compulsory, but for a simplicity for understanding purpose, I have changed it. Then we have option of keeping the file system as the property for this repository. So this is the way we define the repository. So here spring.cloud.config.server.get.url, and then after that the value is like this. So if you are using a file system, then you have to declare a file type of protocol, and then double slash, and For Windows, you have to give triple slash for working with it, and then you can give the path of your config, the repository, that folder, whatever you have created, that folder path you have to give. If you want to go with the get URL, you can provide the get URL like this. As this is a public get URL, you don't have to configure all your public and private keys. But if you are going with a private repository, you have to look into the private key management part and public key so that you can work with them. And also I have given some more property. These are not required for Cloud Config Server. These are the only property which can make your application as a Cloud Config Server. Then what next needed is we have to enable Cloud Config Server. So enable Cloud Config Server will enable your Cloud Config Server application. This is a very basic implementation I'm giving. You have customization over it. You can add more properties and configuration to make it a real-time application. This is just for learning purpose, which can be customized to a higher level production ready application. So this way we are able to configure a cloud config server. Let's try to run it. So I'll run that one so that we'll get a cloud config server, and we'll see how exactly the values can be exposed through the HTTP service. So just by hitting that HTTP service, we'll able to get all the properties which are available in your application.property stored in your repository. So you can see that the application is started at 8888 port. Let's go to the browser and we'll see this. So what I did is, in my local host 8888, this application is running. And after that, I have provided the application name. This is the application name. How does it identifies it? Which properties it has to load it is through this name. So this is the application property which I want. By default, my application is running here, localhost this one. And after that, these are the parameters I have given to this URL. So the first parameter is the application name. As I told, the first parameter will be the client application name. Here, it has mapped that one from the repository like this. So config hyphen client hyphen app is the client application name. Then I have given a profile, active profile. What is the active profile? Is dev profile I have given. Based on that, it has loaded all the properties available. It has loaded uh, the default property as well as the dev property. So you can see that this is the dev property file, which is having this property, which we defined, and the default property. This is the default property it has loaded. This is the default value it is here. So it has loaded everything. Now we have another option also. Like if you don't want to give dev profile, you can go with the default profile also. Based on that, it will load the default values. So based on that, it has loaded only the default value available in our config client app.properties. So both the option we can go with. If you want the client application to be of type dev, you have to give a active profile as dev. Then it will become a dev application by loading all this dev property. If you don't give anything, it will become a default application without loading the dev property. Now the next component which we saw here is the third component is the client application. So let's go to our IntelliJ and we'll create a third component here and we'll see how exactly it works. So for that purpose, again, you can go to s- uh, start.spring.io, and here you can download an application by configuring the dependency. So what dependency it will require is, so config client is the dependency which is required to become a client enabled with the config cloud server, so that this client will have the knowledge of how to pull the configuration from the cloud config server. So this dependency will be required, and also we need another set of dependency which is actuator project. So spring boot actuator, this is one of the project which is required to deal with like the refresh mechanism. So what it does it, so when the application is running, it will provide you some API for interacting with the, like, how is the health of the application, what are the system metrics, like how much load it is taking, how much memory utilization, like that. It manages internal state and everything for getting the details. So we'll use this actuator also. So these two dependencies needed, actuator and the client config, config client. There's two dependencies needed. After that, your application will be ready for pulling all the configuration from the cloud config server. Then we need some set of property changes so that it will know where exactly the cloud config server and other details. So let's go to the IntelliJ and we'll see what code configuration we need it here. So as I told, the dependency wise, uh, so here we have actuator, we have here, this is the client, this is the client, whatever I told, the cloud config client is needed for that. So these are the main dependency we need, and also Spring Boot web, which is for the getting the all the REST services and other things here. So these dependency I have used it here. After that, what changes is required is application dot property. So one more important point here we have to look into, like, when does this application, the client, when does it loads the configuration? That is one of the very important point we have to look into, like load strategy. Load strategy is needed because what happens is when the application, client application starts, before starting the Spring context only, it should know all the properties. Then only it will be able to create your beans and other uh, application dependency, like database property. Without database property, application will not start. Your Spring Boot application will not be able to generate your data source objects and other objects needed for connecting with database if it does not have that properties, so where to connect. So for that purpose we have a load strategy, so that application, before startup only, it can load all the configuration, whatever the properties are there, it will load before the application start. Before the Spring context is initialized, those property will be loaded. For that purpose, we can define those property inside bootstrap.property management. Here we will define whatever we define here will be available before the Spring context initialization. And the client also, cloud config client, knows how to deal with these property and load all those configuration before the application startup also. So what are the property files will have, what are the property it will have is, like, this is the first property as I told, the name of the application. So we'll define the name. Based on this name, it will go to the cloud config server and load the property. As you can see here, cloud config client app is the name which we defined inside our repository also. So here config client app is the name of the property file, and there it is the name of the application. Based on that, it will load this property file from the cloud config server. The next property is where exactly the cloud config server is running. So you can see this, what exactly URI is defined here. So cloud config URI we need to mention, where it will give, you have to provide the, what is the location of your server location, where exactly your cloud config server is running. The third property is active profile. As I told, based on active profile, it will load either the active profile property, or if it is not provided, it will load the default property. Another set of property which is required for this management API endpoint to be enabled. This is for the purpose of refresh API. So as I told, like actuator project is there that provides some set of API, but as part of latest Spring, these are blocked. These are not exposed by default. You have to enable it by enabling in the property first. By this, we are enabling it. We are enabling the refresh API so that it will be accessible. And also we are disabling the management security so that this refresh API will not require any uh, security credentials to be verified, then without that also we'll be able to access it. As this is for the purpose of learning, we are not dealing with security and other aspects. Another video I'll come and I'll explain all this, like how to deal with security and how to manage the security credentials, everything. So by this definition, we have defined a cloud config client. So this application will be ready for pulling all those client config property file. We don't need any other annotation or any other property changes. With bootstrap.property, it is enough for making an application ready to pull properties from the cloud config server. After that, what I have done is I'm using one of the property. So here, like as we defined property one in the property file, so we'll try to expose that property by using a controller, REST controller I have defined, and in that it will give you the property value. Again, we have one more problem here, which is with the beans which are already initialized. As application context initialization, the bean will be created. So in Spring, application beans will be created, or the configuration, whatever the configuration is loaded with that, some object will be created in Spring context. So those objects are throughout the life cycle of your application will be constant. It will not be reloaded. It will be a singleton type. With that, the those property will be available for the purpose of changing some property. Like, consider you want to make changes to your database properties, like your password is changed or something. In that case, those beans will not be loaded, as those beans are created at the very beginning of your application, like application context load. That time only it was created. So those bean will not be reinitialized. Even if you apply changes to your property file, those property file will not be loaded by these kind of like data source and these kind of beans which are already being utilized. For the purpose of reloading those configuration, you need to have this annotation refresh scope, so that when you call a refresh actuator API, it will reload whatever the configuration is you have provided, and it will recreate the beans for you, so that those beans will have the updated values. Based on that, it will make a connection, or it will start logging based on the different level. So this is required for that purpose. So we have defined this application as a client which is capable of pulling all your configuration for config server. We'll try to run it and see how exactly it works. So this is the main application. We'll try to run it. If you and you can see that here, these property load are logged inside your log. So these are actually your properties which is getting pulled from the cloud config server. You can see it at the bootstrap time only. These properties are loaded and the application is having this latest properties. So this application is started and we'll try to hit the service and try to get the property whatever we have defined. So as the active profile is dev, so if we try to retrieve this property here, this will be the property whatever defined inside dev. So let's try to hit that API and see how exactly the value will come. You can see that the property which is loaded here is the dev property. If you will change any property in your repository, you can retrieve it again from this. So that's all as